Okay, welcome to my talk. This is a perspective paper. This is a joint work of our team at these universities. And in this perspective paper, we'd like to address how evaluation of generative ad hoc information retrieval systems could work. We're trying to ground this all in traditional IR and bridge it to this new era. I'd like to make quite clear at the very first point that this is related to WAG evaluation, but we're doing it slightly differently here because we're only focusing on ad hoc systems that give the answer to the user right away, so no back and forth required. And also, we are not taking the same steps as a WAG system for granted, where we would have first retrieval and then the generation of a text. We leave that to the system. But those are minor details. In essence, these things are really applicable also for WAG systems. And I will show that later when I will relate this to track WAG. So let me start with two quick definitions. First, what is a text SERP? Text SERP, in contrast to list SERP, just gives results as a single coherent response with sources, so kind of this replacement of the 10 rulings format. And the second definition, I'll define the synthetic search task. So we want to relate this to the definition of, or the taxonomy of Broder for search tasks, which is quite old already, but still applicable here. The first generation of such systems had a user intent that the user wanted to use the system to acquire documents, but GenIR goes beyond a single document. The user wants to reach the documents, but in GenIR we don't really want to reach a specific existing page. We want new content, or at least a new document to be generated. And also this performing of the search is not really done in GenIR because we also have information condensation done on the system side. Not the user has to go through all these pages and aggregate the information themselves. It's done by the GenIR system. And this is what we call this condensation step here in the, as we call it, fourth generation of search tasks. GenIR systems go beyond these existing tasks. And here's the definition that we gave for synthetic search tasks. We have a single comprehensive generated answer document. So no back and forth there in response to complex information need by condensing the information from multiple sources. So let's motivate our structure here, how we really want to approach this evaluation problem. There's no systematical investigation yet, but we have all this knowledge that we've accumulated over the years in traditional IR. It has been investigated for decades. We have a robust theoretical foundation and even a proven reliability of the evaluation in practice. In GenIR, we don't have that yet. It's recently emerged, no theoretical foundation yet, at least when it pertains to the evaluation, no practical experience. And here, we want to take this opportunity and transfer all the knowledge from traditional IR evaluation to this new paradigm. So here are the traditional steps one would take when attempting such methodology. In traditional IR, one would first define evaluation objectives that really capture the task that the user is trying to achieve. Then we would derive a corresponding user model, which serves as the foundation of our evaluation, and then really operationalize the user model for experiments. So at each step, our method was to survey existing literature from IR and related fields and apply it to the concepts of the new task. So we have some objectives, user objectives that I talked about, that we ground the information search processing. This is all from a user perspective here in the traditional process. After the formulation of the information need, the traditional IR system user selects some sources from the listserv for further investigation, analyzes these sources themselves for relevant information, and combines the information found in the sources. We call it a synthesis. And some of these steps are now taken over by the system. So in GenFFIR system, the system partly replaces these steps of selection, interaction, and synthesis. And now these become our evaluation objectives. So a generative IR system should identify the relevant, informative, correct, and diverse sources, use the grounding steps, so correlate the generated output with sources correctly and consistently, and present these to the user, so condense all the information, aggregate it into a single, concise, coherent, and accessible form. So these are the objectives, and now we will use these steps to actually relate them to a user model. So first, as an overview, offline IR evaluation experiments are grounded in a user model, and we have 3 components for these user models. At first, utility, which describes how valuable an information piece, or in this case a result, is to a user. The browsing behavior, so how the user proceeds through these results. This is especially important if you have these list SERPs where no one ever clicked through all pages on a Google search result page. And accumulation, so how users really combine these information across results, because our assumption is that users are never really happy with the very first result that they click on. So in traditional IR, we can easily map this to NDCG, where utility is represented by a gain function, browsing by a discount function that decreases over time, and accumulation is done by computing an expected total utility. And now we have to bring it over to GenIR, and in our paper you can read that we motivate specific instantiation of these instances. Let's have a look here. One thing we first need to do, because we have a single text, we need to approach this granularity step. Because on text SERP, we have one text, and we have thus different levels of granularity also for the evaluation. We have a response level evaluation and a statement level evaluation. And this is also what we saw in the previous talk, that this is an important choice to take. So see the term of nuggets and so on. On a response level evaluation, the text SERP is annotated as a whole. And we see a single label, and we can directly use this to describe the utility values. But sometimes it's more feasible to actually do a statement level evaluation, where we split the SERP into some statements, whatever their size might be. I'll come to a specific instantiation later, and perform an aggregation over the statement labels. So we need some form of aggregation measure, and this is also what we saw with NDCG. So the evaluation objectives are now implemented differently depending on the granularity, and now I come up with a table that lists all of those. So these are the objective steps that I introduced before. And we identified 5 main utility dimensions that split up into statement and response level. Correctness means that on the statement level, the information is actually factual, reliable, and relevant. This is also perhaps like a very like a statement that obviously makes sense, that we really want to check out on the factuality. We also saw that in the previous talk. But on a response level, another dimension comes in here, because we also want to reflect a broad range of in-depth information. It's no longer sufficient to pick out a single source, but rather we should aggregate and reflect every side that there is. This also somehow contains that we don't run conflicts between our sources, but maybe there are conflicting opinions in our sources and so on. But now it's up to the system or our evaluation in this specific step to check whether these conflicts are resolved by giving additional context, giving additional information about that there are actually different opinions. And this is precisely what this consistency step says. So, for the statement level, we really want to accurately convey the sources and not just hallucinate some input that comes or that is not contained in the external sources. And for internal consistency within our response, we don't want conflicts between information, we want them to be resolved. And for the last two dimensions, for the presentation, so for the last step in our objective chain, we want a good clarity, so a statement on a statement level should be expressed in a clear and user-accessible manner. And coherence here means that the response should be arranged in the form of a coherent narrative. No breaks, not just a simple concatenation of statements that you would expect in a list serp. Now let's have a look at the next component of our user model, which is the browsing scheme. So traditionally, we have this CWL framework known from traditional IR, and this really models how users behave if they are faced with a chain of information in this traditional list serp. And there are three relevant effects that we observe. Progression, so the user reads the text sequentially from the start. Now we have text serps again. Decay, the attention diminishes. And saturation, users abort reading at some point because even with the text serp, they sometimes don't want to read the whole answer if they're satisfied with the information. Thank you. So traditional IR browsing models can be transferred to generative IR because this all maps perfectly to our texts. So as a summary, what evaluation experiments are needed to actually do evaluation of these systems? So we have a setup stage, we need some documents, we need some topic set with queries, and we need these generative IR systems. Here we propose adding a pre-processing step, that's the segmentation step, be it splitting the text into sentences, and the annotation step. So either a human or a model or both combined in some way has to do the utility assessment by those criteria that we define. And then we need a measure to measure the evaluation and aggregate this all. And these three stages here have to be informed by the generative IR user model that we showed. And this is an important step to take when justifying evaluation tasks, for example. So let me summarize this and then also relate this to how existing systems already implement this in experiments. So we introduced this new synthetic search task that's a bit orthogonal to traditional tasks, and we survey existing evaluation methodology and transfer to this new paradigm. And we provide a systematic theoretical foundation for GenAI evaluation experiments. What's now left to do in current and future developments? So first we have TrackRag, which actually adopts a compatible evaluation methodology. So thanks to Janek, we had nice chats here in Washington, and he explained me how this really relates to our ideas, and coincidentally, TrackRags form some sort of instantiation of our framework. So what's left for us to do is the verification of this method through some user study, and also checking on the possibilities of model-based evaluation to not having every single step done by a human over and over again once a new system emerges. The ongoing issue. So let me quickly jump into the details of how TrackRag does this here. Thank you. These are the slides that you have seen already, but so for this granularity issue, how are the responses split up into statements? TrackRag uses segmentation into sentences because it's easy in both segmentation and evaluation. For those utility dimensions, TrackRag plans to detect hallucinations for a human annotation of bad nuggets, but misinterpretation is not yet really explored. And coverage is checked by checking whether all relevant nuggets are actually used. Consistency is checked in TrackRag by checking whether statements are actually conveyed by the sources. And internal consistency is planned to be checked. And for the last thing, clarity, TrackRag uses statement-level clarity metrics, and they plan on doing it on a response level with coherence. And for the browsing model, they plan to do aggregation by averaging utility over all sentences, and they have a tweak there. They enforce the maximal response length to punish redundancy and really imply this browsing model that has some sort of decay or saturation. So yeah, that's my talk about how we think evaluation of these systems will work, and I'm looking forward to your questions.